afternoon, ladies and gentlemen. Thank you for your interest in unstructured data. In my presentation today, I prepared the content about building NAS for a business critical application because typically in the past, I guess everybody had experienced that network attached storage was something like synonym for dump storage or something like data swamp, nothing important. What we can see as a big trend that our customers, and not only at our customers, that unstructured data, like data that are stored in some file systems or object platform or in the object cloud, become more and more important, and for many customers became this type of data or workloads like business critical application, and it has similar or in some cases even bigger importance and value than traditional IT systems. So, unstructured data, which data it is? We have this, let's say, splitting the data around the structured data. Structured data is our data that are stored in some databases, virtual machines, and structures like this. It's quite solid, portion of data, but there is a not so big growth, like 10–15% per year. Nothing special. You hear lots of information about different block storages that is typically used for it. But the more important thing, I guess, it's unstructured data, because in unstructured data it's not only about office documents like these office Excel, Word, and so on, but we can see today lots of different sources of data, different type of data that become more and more important, and many customers deal with it. And in my presentation, I would like to give you some thoughts and ideas how to build platform for such a workload, how to manage such data, and had some introduction of our platform from our kitchen, from DELL TECHNOLOGIES, how we deal with such a data. As I said, data, unstructured data become a very valuable asset of the companies. We have plenty of customers, not only from media, but from manufacturing, from automotive industry, or from other industries, where these workloads are become really important, and they started to pay attention to this topic. First of all, how to design storage or network attached storage for such a data. There are the, let's say, key thing that you should pay attention and take into your consideration with all these growth and enormous growth around unstructured data, regardless industry. It's mainly about the application or machines that generate this data. Typically, it's not like that users in some company produce like petabytes of data or even tens of petabytes of data. Typically, this data comes, or this important data comes typically from some machines like IoT sensors, from some computing platforms, and so on. Typically, these data are either created or accessed or treated by some application. And it's a little different discipline to build a platform for such a workload, because you need to start any consideration from the application. Because if you start from typical Excel, typical approach, like we saw, say, 8 years, 10 years ago, like build some easy block storage and then put some filler on top of it. For many applications, this will not work, or it will work for some certain period, but not forever. And designing such a systems is, as I said, it's about application. It's not about how many IOPS this system provide, how many SSDs is inside, how many controller is inside. It's about if the application that you need to run, or that access your unstructured data, can work on it, can perform on it. Can I grow the data on this platform with this application? If this application will be ready for new things that I even don't know at this moment. So this is really important to start from this point. As I said, if you design typical block storage, whatever block storage for VMware, for some databases, there is only a few information that you need to know. typically how much capacity I need, how many IOPS, in some cases even block size of these IOPS, performance queue if I need to create a hybrid solution, some data services if I need synchronous replication, asynchronous replication, integration with, for example, VMware, with Oracle, whatever. And if I have this information in one place, I have quite solid input to build the storage. If I want to build the storage for example, for collection and processing data, for example, from some factory, like IoT data from some sensors and machines, it's completely different discipline, because I need to understand the application, what the application needs, how this application works, which protocol use, which settings of the protocol, typically like for NFS, should be configured to make this application work, and of course what is block size of this communication, because if I will run NFS with 16 kilobyte IO operations request, it's completely different design than if I will run NFS with 1 megabyte block size communication. Another specific thing that comes into account is performance. Performance, it's a different type of information. One important thing is, and this has become more and more important, is aggregated performance versus single stream or single session performance. Because typically many applications in the past was quite fine with 100, 200, 300 megabytes per second, which wasn't a big deal for many platforms. But today we can see lots of applications that need like half gigabyte, even 1 gigabyte single stream throughput, which is really throughput that you need to be able to put into the one session, like for example one NFS connection or SMB connection, and be able to provide this performance. And this is something that the traditional systems like unified storages, like Windows servers and so on, are not designed for it. So this is important thing for many applications. We can see typically in media, it's best example. If you have like layout of some videos, you know that this one single stream for one channel can be, for example, 130 megabytes per second. Second point is aggregated throughput. This is how much data this platform should be able to transfer out or in over different connection or different type of protocol, and typically how many decisions I must handle. For example, you can have application that need to handle, I don't know, 100 sessions, and each session need to have at least 100 terabytes, and then you can see that the design is can become quite complicated. Another important thing that architects usually doesn't pay attention is number of files and file size. We had lots of customers that built a NAS platform, then they started with like a couple of tens or hundreds thousands of files, and it works fine. Then they put new workloads, and now they had like 1 billion files, 2 billion files. It's not exception. Even banks. I had one bank in my country where I'm from Czech Republic. They have one bank, and this bank on their quite small file system, like 40 or 50 terabytes, they have almost 2 billion files, which is crazy. I don't know how they did it, but they have it. And if you, for example, need to only list it the folder where I have thousands files or even millions files, it will take ages to get response. For these cases, you need to count also this parameter to be able to design a system that will have, for example, metadata acceleration and so on. And almost the last thing that you pay attention is capacity. You can see that if you design such a system, the capacity is not the first thing like with block storage for VMware, but capacity has become really one of the last information that you need for design. And the last, not least, data services. If you need some data services that you need to run on this data, like replication, central SCORA management, protection with retention policies, and so on. So this is let's say from sizing perspective consideration. Then there are architectural consideration that I don't want to say that you must, but you should also consider. How to integrate such a system to application environment. How your application can communicate with the system. For example, you can see some applications that run over SMB protocol, and they perform only on SMB, for example, SMB3, because they use some specific features that is implemented only in SMB3 protocol, like multi-channel, whatever. But if you will run some block storage on top of this storage will be filler that use Samba org implementation like reverse engineering Microsoft SMB protocol, it will not perform for this application. So lots of things to think about it, about how to integrate application to the system, how to manage connection, and so on. How to manage such a system. We can see on the market lots of platforms that are built typically on some open source hardware, that you have like some really stupid block storage and then plenty of fillers or servers that provide you some clustered file system, whatever, with thousands of commands in CLI, which is beautiful for guys it's from academic sphere or some technical universities because they love it. But in enterprise companies, you don't have time. And I guess I'm the Linux guy, but I have much better things that I want to do than learn another CLI command to manage something. So how to manage system that, for example, store 1 million files in a couple of hundred terabytes and need to provide some certain performance. Another thing that customer in the past didn't pay attention so much was security. So today with GDPR and all these crazy stuff, like you got project from external companies and that companies require some level of security or data governance. You need to check if you are compliant with it. You need to have tools how to protect the data from unwanted access from other users. How to make it. Backup file data is another my favorite discipline, because if you have file system like this in this bank, they have 50 terabytes, and if you call guys from any backup company and say, hey, I need to backup file system 50 terabytes, they will tell you no problem, we have perfect solution. But what about I have this 1 or 2 billion files, and every day is changed like a couple of thousands or even tens thousands files. When I need to make tree walk of such a file system to get information which files should be backed up today, then this tree walk can finish when my backup window is over. So you need to have also chance to back up your file data, and this can be done only if you have implemented some smart technology like snapshots, differentiation, and so on. One nice important thing is how to migrate data to the new solution. Migration data is always painful process. How to migrate plenty of data, like hundreds of millions files, take ages. How to treat file permissions and other things related to migration. And then, what is the future? Typically, when I ask our customer, even from the area like automotive, where they have quite clear of unclear future information, they usually say we have no clue what we will run in the future. If our application will need this performance or 2 times more gigabytes per second, if we will ended up, if we start from 100 terabytes and we will ended up in 1 petabyte or only half petabyte. So, and data lifecycle. I have for example, one customer that have under regulations data that must be kept for 30 years. 30 years, they must be able to prove that they have data from some sensors they produce. Which is, again, nobody knows what will be in 30 years, and I'm sure after 30 years we will not use this, we will use different technology. But you need to have chance, at least in short periods, to manage the data when they are beyond this standard life cycle of the hardware, to have chance to make it. For example, if I need to keep data for 10 years, I should have chance to keep the data on a single platform or single platform for 10 years without migration data every 3-5 years. And also how to make technology refresh. Technology refresh means after 3-5 years, your system is, I don't want to say obsolete, but it's not so nice, fast, or whatever, and you need to make technology refresh with it. If you have quite complicated NAS environment, it's not so easy job, and sometimes it's hard to avoid another not so easy or even painful migration. So this is the thing that you should take into your consideration, and then you will choose, I guess, today like 4 platforms that give you quite solid and clear information how to manage all these challenges. As I said, it looks quite complicated. It's my favorite actor, Mr. Bean, but I don't think that it's not necessary. If you use proper approach, if you take into consideration the information that I gave you, because I do it every single day when some customer asks me for a design of something. I ask him or myself for most of this information, and then do my proposal what should be designed. And as I said, the unstructured data is not easy, and you should pay attention to the vendors that take unstructured data seriously. I don't want to say the guys that produce block storages don't care about unstructured data, but they run integration with VMware, with Armen for Oracle, but they actually don't care so much to manage complicated NAS environments. So choose typically purpose-built solution. Today you have luxury that you don't need to combine some conventional or legacy or old-fashioned block storages and looking for some, I don't know, open source or new fancy file stack on top of it. So now you can see on the market lots of purpose-built solution, not only for unstructured data. If you take a look at the IT today, you have purpose-built solution for VMware, for Oracle, for SAP, for artificial intelligence, for analytics, for many things. So don't limit yourself with some legacy architecture and choose a purpose-built solution. And what I need to add is with proper architecture. Proper architecture, I guess it's really important because with, for example, our platform like unified storage, which we have, for example, Unity, it's a nice situation because you have typically 2 controllers. If you are lucky, you can have 4 controllers in such a system. And then you put some disks inside, it performs somehow. But if you need to put another workloads or accelerate some workloads, you can very easily to get to this point when there is no way to increase the file performance, just because of you simply hit the limit of the controller. Which means with Unity you need to exchange controllers. In some cases even the higher or better controller cannot give you the required performance. And then some guys try to put another shelf of SSD, and then they see that, hey, we put another SSD, and then ended up in the situation that they have so many disks, even fast disks, but the file performance, which is done on controller, not on the disk only, it's even lower. So this architecture is perfect for VMware, for Oracle, and things like this. But for unpredicted growth of file or object data, it's better architecture which is called scale-out. Actually, it's not only about unstructured data. Scale-out architecture is, for example, vSAN. Scale-out architecture is architecture where you build your solution from building blocks, and each building block has the complete functionality, compute, capacity, data services, and you scale your system as you need. It's like VMware. If I need 4 ESX servers, I use 4 ESX servers. If I need 10 ESX servers, I use 10 ESX servers, and it's still one virtual environment. So this is the same with storages. Today you can see hyperconverged system for VMware, for other applications. And in unstructured data, I guess this is today only way how to safely build the platform for unstructured data. Because, for example, many of our customers started with us from archiving, because they said, okay, we are a new kid on the block, we don't know if we can rely on your platform for more critical workloads. So they typically started with us, they put some archive platform on it. Then they like this technology and say, okay, we want to run this application, this workload, but we need completely different performance. But what this customer did, this customer bought another building blocks like new ESX server, but not with one CPU inside, but for example with two CPUs inside, with like analogy. So they they scale the capacity and the performance like this, and if they will need to scale the system further, they can again linearly scale system, and the sky is the limit. Today, it's, for example, our platform, the limit is 252 nodes, which I guess is even enough for big companies like Facebook and so on. But this is really important. You can choose today from scale-out architecture from different platforms, from different vendors. So again, don't limit yourself and rely on the platform that allows you to build something today without knowledge what will be in next 12 months, 2 years, 3 years, whatever. And if new requirements, new demands will come, you have at least chance to scale the system and ensure that another application or workload can be put on it. What is very important, and what we are proud, because this is our strategy. We are not fighting with our competitors on number of SSDs inside, or who has the most beautiful Bazel or most beautiful GUI, but we won over our competitors on the knowledge that I mentioned on the beginning, about the knowledge, the application. We have large team that is spread across the industry, horizontal solution, and this team talked to application vendors like, for example, CAD vendors like Autodesk, like Katia in healthcare, to vendors of PAC system, vendors that provide application for analytic stuff, whatever. And we have thanks to this team, we have information how, for example, this PAC system or this CAD software or this backup software, this archive platform works, what this application means from infrastructure, how to design this infrastructure, and we can make very easily pretty accurate design for this particular case where, for example, if you build CCTV system, you have like 3,000 cameras, like Metropolitan CCTV system with Milestone. We have configuration guide, design guide, deployment guide for Milestone, and you are safe, because if you follow this recommendation, would be tested and validated with the vendor of your critical application, then you are safe, and you can build a system that will work. I have one spedition company in Czech Republic, and for them, for example, CCTV system become mission critical system, because they use SAP for all this processing orders, payment, and so on. And they need to have field evidence that the load that they put on the track was undamaged, that left, for example, some building, it's on the way, and so on. And they use CCTV system and store this proof of quality, or like they call it field evidence, and they store it in an SAP system. And then if CCTV system is down, which means for them we don't have field evidence, then SAP said, okay, no production. Make up and running CCTV system, and we can ship another truck with the load for their customers. So for them, it's really CCTV is most important, and they rely on us because we show them, hey, we have this design with your vendor of your CCTV system, and it works like this and this and this, and check it with them if it works or not. Our, let's say, flagship in this for this unstructured data, we have of course more platforms, but I would like to emphasize today ISILON, because I guess it's quite attractive technology for the customers typically in Eastern Europe, for our scale, for our type of workloads, and so on. We are on the market 18 years, so we are not the new kid on the block anymore. ISILON was established in 2001, and in 2001, when every other vendors like IBM or HP, they had some block storages and take care of completely different thing. We started the first one with scale-out architecture. We built at the time first scale-out file system, and then improve it year by year. And after 18 years, we are again number one. We are, and I must say that we are number one because of this application integration and knowledge. Without this, we would be lost, I guess. Scale-out architecture means that, as I said, you build a system like Lego. Everybody knows Lego, so you have, for example, super fast node, super lazy node, something in the middle, and based on your requirements for your application, you choose the proper type of this Lego bricks with the proper capacity, and then take required amount of these Lego bricks into the one system, and then you have, for example, in this case, 3 Lego bricks, but you manage it as a one system. It's one system that comprises 3 Lego blocks or Lego bricks, but it's one system. It's not the new approach. Who knows the network stacking from Cisco from, I don't know, 2008. It was the same technology. You stack catalyst switches and you manage it as a one system, not as a single switches. What is nice on this architecture that allows us to use similar principles like in a virtual environment. You know resource pool from VMware. You have resource pools, vCPU, VRAM, and other resources, and we use the same approach. We have a resource pool of CPU power, RAM for caching, capacity for storing data, and treat it like resource pool in VMware. And this capacity, this pool of disk, we don't use RAID groups, we don't use volumes, we don't use any other legacy technology. We simply create one pool, use software define storing data with some smart algorithm how to make it, and we have single volume and single file system that can start. I guess the smallest configuration today is like 17 terabytes, and you can scale it to I don't know how many petabytes, because theoretical limit of the system is somewhere in the sky. But typically you can have 1 petabyte, 10 petabytes, whatever you can have in one single file system. You don't need to have for 1 petabyte storage, you don't need to have like 100 terabytes, another 100 terabytes, another 100 terabytes. You don't need it. So you can have it in one file system, and then you can make, of course, separation, protection, blah, 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 on logical level. We have the different type of building blocks. I like to use this analogy. Everybody likes cars, or at least understand cars. So we have super fast car like this Porsche. We have quite solid and sometimes even pretty fast hybrid nodes, like typical production nodes. And then we have also A nodes, which is A like archive, that are not so fast, but they have very nice and attractive price per terabyte, and allow us to store either, let's say, bigger amount of data or much bigger amount of data with high density nodes. If you have cloud strategy, and cloud strategy can mean also I will never go to external cloud environment. But if you sooner or later will have any cloud strategy, for example, you will have contract from Amazon, you can very easily extend your infrastructure to Amazon, map some capacity from Amazon, and then have it as a logical tier on ISILON. It's possible, and you can very easily extend the system with the same features to external environment. I'm not a big fan of this idea, but it works. We have a few customers that run ISILON in this scenario. Why not? Then if you make all these things, the architecture is not so complicated. It's quite easy, because you have this cluster of these Lego bricks that is connected with backend infrastructure, which was in the past InfiniBand. Now we use Ethernet. And on the front end, you have all these protocols that you expected from the system. You have NFS, you have SMB, SMB3, including all these fancy features like continuous availability, multi-channel, encryption, blah, blah, blah. I don't know why Microsoft introduced encryption for SMB, but they have it, so we implement it. You can access the system over HTTP protocol. For example, if you have applications that need to be integrated or access the file system through some API, so you have RESTful API that can be accessed over HTTP, and of course FTP. It's legacy protocol, but still many users, because of old application, use FTP. What is quite interesting and big differentiator, because nobody else doing this like us, we built a distributed file system for Hadoop environment. We rewrite it and we create a distributed file system as a file protocol. So if you want to run Hadoop analytics environment, you can store the data on ISILON and then access the data from your computing farm over HDFS, which is fully transparent to a computing environment, but the data can stay on ISILON and can be very easily streamed to this environment. There's a nice story behind this. If you have a Hadoop project with capacity, let's say at least 50 terabytes, 100 terabytes, we have very nice story and lots of benefits. Many customers use this architecture. Typically, our biggest customers for this Hadoop stuff are security intelligence services, because they collected everything and then they run their crazy analytics on top of it, and this is the case for them. As I said, it's Lego. Lego means that I can extend the system with another Lego brick. As your system is filling with the data, then if the system is full, you can very easily extend the system with adding another Lego bricks. So you extend the system, and on the background, the system spread the data also among the new nodes and balance the utilization of all these nodes into the equal level. This is automated. You don't need to provision any new RAID groups, dedicated some spare drives, spare nodes, whatever. It's nice because it eliminates also hotspots. We had lots of customers that use VNX with this NAS filler, and they had issue that, for example, I can use this picture. They have, for example, some volume that was like this, that was under heavy load, and they needed to increase performance, which means at that time you need to put more disk, redesign storage, blah blah blah. With the new pool strategy, with the block storages, it's easier, but still you need to create some pools and volumes, and it's not so easy to scale it. With ISILON, you don't have it, because you have still your one file system, and the rest of it is done on a hardware level. Easy management, I always used to say that easy management is not about the most beautiful GUI designed by some Apple designer. I would have a GUI from Apple designer, but this is not about easy management. Easy management means how much effort per week, per month, per year you need to spend on managing your system. And with ISILON, we have plenty of customers that have like 1 petabyte or even or more capacity in the system, and it's managed by one single guy, or there are two guys just because of vacation or sickness. But you can very easily manage it by one guy. In the past, large infrastructure was managed by a huge storage team, because they had to deal with lots of these volumes, mapping, balancing, blah blah blah. So this is about easy management. With ISILON, we get rid of all this infrastructure management, like provisioning, balancing, and so on. You manage the data. We want you to store the data, set up permissions, quotas, create snapshots, but even snapshots can be automated. So this is how we understand easy management, and this is one of the reasons why our customer buy ISILON. You can create more tier system. You can have, for example, archive tier for cold data, which is data that are not so often accessed. You can have the top performance tier for some, I don't know, analytic processing data, for example, from IoT sensors in some factory. And you can very easily balance the data among these tiers with automatic policy-based tiering, which enables you to consume the capacity with proper price per terabyte and eliminate overloading, for example, off-flash tier, and it can be automatically. You can define policy file bigger, older, access, then some parameters automatically tier to archive, and system will do it. And will do it at the time when you need it, for example, in the night. And my most favorite part, because in my previous job I worked for system integrator, and I was involved in many migration projects, and so believe me, I know how sometimes migration is painful. With this Lego architecture, you can very easily extend, for example, generation 5 cluster with nodes from generation 6. Today we have in one rack 4 rack unit chassis 4 nodes. And then extend the system, you create the new tier, or we call it the new pool, and then you will tell the system, please tier data blocks from old spindles to the spindles or flash drives in the new nodes, and it's tiering. It's not migration, it's steering. Which means that network settings, file system permissions, shares, exports, quotas, snapshots, replication policies, worm, everything on logical level stays same. So for you, it's not migration anymore. And this is the way how you can work, and many customers work this way, because they, for example, have like this 10 years mandatory retention for data, and how to make it 10 years. You will keep the 10 years old storage in your infrastructure, no way. So this is the way how to make it. Avoid migration, avoid breaking retention policies, and you can make it. You can do it very easily. It's like a few clicks in GUI. One thing that I want to emphasize, because we received many questions from customers that they are looking for a huge capacity. Hey, I have like 1 petabyte or half petabyte project. Please size me storage with 10 terabyte drive or 12 terabyte drive. If you have 20 terabyte drives, thank you. Please make it like this. The one important question about 10 terabyte drives, I hate this size of drive, is if your 10 terabyte drive, which is utilized up to, let's say, 70–80%, how much time you need to rebuild it? And how much performance, and what will be the performance penalty on traditional system like whatever, unified storage, will you cost? 10 terabyte drive will be rebuilt in best case in, let's say, 6 days, maybe 7 days, maybe 1 week. On some slower platform, it will be even 2 weeks, 3 weeks, no problem with such a large drives. With this clustered architecture, we have this luxury, as I said on the beginning. We have this resource pool. That, for example, if your drive failed, I have, yeah. Whoa. For example, you fail drive in this node, then start immediately process and start rebuilding the missing data. But you can consume on rebuilding this single drive or even more drive CPU from every single node in the system. If you have 4-node system, you use CPU from 4 nodes. If you have 12 nodes system, you use CPU from 12 nodes. And you have even this luxury, because on the backend is Unix, and with Unix you can play a lot with the processes. We can set priority for this process. We can, for example, say, okay, for this rebuild process, consume during the peak hours only 5 or 10% from each CPU, which means I can handle very easily production on the background. I can rebuild the drive, and during the night, take it whatever you want. And then your drive will be rebuilt faster, sooner, and you can control the performance impact on your production. And we had some cases, customer bought a cluster, it was broadcaster, quite critical infrastructure for him, and he realized that he has failed drives. Then our support called him, hey, dear Mr. Frida, we are bringing you a new drive. Say, drive? Yes, actually 2 drives. And he didn't realize that 2 drives fails in the system. So we bring in the new drives. It was rebuilt quite fast because he has a big cluster and no problem at all. And this guy continued with us because he made migration only beginning in 2014, I guess, or 13. And then he made 2 tech refreshes. And tech refreshes like this, you extend the system with the new generation, make tiering, and that's it. So no migration, no downtime. And when he faced the situation that 2 quite big drives failed, no impact on production, and it was rebuilt very fast. With this software's protection of the data, you can choose on directory level on file system how your data is protected. For example, the default level is like RAID 6, protection against failover 2 drives, one node, or if you have some concern, for example, with big drives like 10 terabyte drives, you can protect you against failure of 3 drives and 1 node, or even 1 node and one disk in another node. You can combine it, and you can create based on your requirements. If you have, for example, a most important project that you cannot lose any data, and you don't have any performance, any CPU cycle for rebuilding, you can mirror the data. You can, for example, for 30 days for this project, for this short time, you can have, for example, 4 copies of the data. Why not? So you make 4 copies, and the project is done, everything is ready. And then I say, okay, dear Mr. ISILON, make it like RAID 6. Thank you. And then after a few hours, you have calculated RAID 6 protection, and that's it. Very easy. Nice thing, replication, failover. This is, I guess, something that you will expect it from us. What we have in our failover application, we have something that every single IT guy will like. We have a dry run for failover. So during the night, typically, the system creates testing dummy data, testing network configuration, and all the settings, and then he tried to make failover to the other side. Log every steps, and then send you in the morning email, hey, I tried to make failover, but I don't know, domain administrator password expired, or I cannot change domain something in domain controller, or network settings on the other side is incorrect. You can get this information before you need to make failover. And this is another thing that make your life easier, and you can test it without affecting production. If you are concerned with GDPR, which you should, as some application vendor said, we have a nice integration with the guys from Varonis, and Varonis can investigate your file system. You choose the classification rule. In this example is, for example, GDPR for Germany, but they have GDPR for every single country in the European Union. And then you choose GDPR Romania, and then he go through the file system and give you the information where in your file system are sensitive data under GDPR regulations. GDPR is not so difficult. Make it in the databases in some portal solution, but on the file system it's quite tough and it's almost impossible. So if you need this, we have it, and it's integrated through API with ISILON. So you can say if you have, for example, this, you can say the action delete the files or change the files, trim the files, whatever, and then Varonis can call ISILON through API, say, okay, delete all these files, create snapshots, and or delete everything from snapshots from file system. Nice one. In some countries, customers face ransomware. I don't know if it's your concern or not. In Slovenia, they were under heavy attack, I guess, 2 years ago. Another application extension for ISILON, we have cooperation with company Superna. Superna created easy application that checking audit log on ISILON and checking what is happening on the file system. If detect behavior which is similar to ransomware, it's again call API or ISILON, disconnect this user, log this file, restore this file from snapshots, and you can very easily prevent your file system from being encrypted by ransomware. And you are informed, you can identify who did it, or at least which bloody user started this storm, if it's based like this typically, very easily against our competitors, doesn't pay attention to these topics. So why our customers that likes ISILON typically buy ISILON for a specific reason, like if they are from specific industry like media, like automotive or some other industries where we are quite very well recognized standard, they follow these standards typically. They like that they can consolidate file workloads on it, and that they can linearly scale performance, because typically our customers is slow to if how the environment will look like in the future, and what will be the new demands in the future. You can combine it with the many workloads. If you, for example, have no need to build dedicated infrastructure for different applications and want to have one system that is nice, like ISILON, you can consolidate different workloads, like putting home directories on it, let the system put, for example, digital archive for whatever bugs, I don't know, some rich media stuff. You can put it, you can make it on one system, manage it as one system, have all these advantages that I mentioned, and you can be happy and have quite calm sleeping. And last thing from my side, there is always not so easy way to find the best solution. We will be really happy if we can help you, because we have this luxury that we can be focused only on unstructured data. Actually, I don't care where Oracle is run or how VMware perform on other platforms. We are fully focused on only unstructured data. We can help you to find proper shortcut for you, just to provide you a chance to avoid situation like Mr. Bean. If you are a fan of Mr. Bean, watch the movie when he tried to make turkey for Thanksgiving, and he tried to get rid of the bone of the turkey, and this was the situation where he ended up. So he would be really happy if he can prevent you from a situation like this, and if you will have any projects and would like to at least listen our opinion about our look on this part of the solution, be really happy. Thank you very much.